athletic fields and performance and safety on athletic fields. So we're going to be doing some work in the biomechanics lab on performance of different synthetic turf and stuff like that. So that's just a little background on myself. So article that I'm talking about today is Physiological and Biomechanical Comparison of Roller Skating and Speed Skating on Ice. And this was done back in 1987, so a little bit older than the articles we've been seeing so far. We'll take a look at what they found. So the importance of this article, basically this was in the frame of Olympic training for speed skaters. So as part of the training for speed skaters, they go through a period in the summer called dry land training. And as part of that, they do some roller skating to try to mimic what they're doing on the ice. Now, a major part of that is obviously you want the training to mirror the activity in the sport as best you can. So the question they started to ask was, is roller skating really a good representation of speed skating on ice? So that's really the main question looking at in this study. So we talk about this term specific training, which really that's the idea that the training exercise that you're doing matches the same way both physiologically and biomechanically in the sport that you're training for. So you get the maximum benefit from specific training, again, because that closely resembles actual performance. So we talked a little bit about the 1980 U.S. Olympic speed skating team and their dry land training. You can see the breakdown here of how they did spent their time during their dry land training period. You can see 25% was spent on specific training. So the question is, can we look at roller skating and determine if it's a good representation of speed skating, and then in turn maybe bump up the time that they spend during the specific training period? So there were a few previous studies looking at roller skating compared to speed skating on ice, but these were basically the old roller skate design of a 2x2 wheel system. So obviously that's going to be something different as you're going around the curves as opposed to the inline skates. And at this point there was no previous inline roller skate studies, so that's really what they were looking at. So for the hypothesis, there really wasn't any, but as I read through, I kind of thought about the friction of the surface when roller skating compared to ice skating. So I went through and made some up here that roller skating will increase ventilation, oxygen uptake, heart rate, and respiratory exchange ratio, which is just the ratio of carbon dioxide to oxygen in the expired air. Increased knee angle, hip angle, and push-off angle, and increased power, work per stroke, and stroke frequency compared to speed skating on ice. So for the methods, the subjects, there were 8 well-trained male marathon speed skaters in this study. They performed 4 maximal exercises, 2 with roller skates, 2 with ice skates, and they were instructed to skate 7 laps as fast as possible. And during that time, various physiological and biomechanical measurements were made. So in terms of physiological measurements, they measured heart rate, and then using a Douglas bag to collect the expired air on the last lap of each test, they measured ventilation, oxygen uptake, and the respiratory exchange ratio. In terms of the biomechanical measurements, they looked at knee angle, hip angle, and push-off angle. And they made a point to say that push angle was kind of one of the important performance parameters associated with speed skating. And to do this, they filmed the subjects in profile and at right angles during at least 2 full strides or strokes. So here's just an example, again, in a picture of what we're talking about. You can see the knee angle and hip angle there in that center picture. And then that push-off angle on the far right picture there, again, as a relationship to a vertical line there. That foot relation to a vertical line is the push-off angle. They also measured power. To do that, the external power needed to overcome friction was calculated using a model of air and ice friction losses developed back in 1982. They also determined the coefficient of surface friction specifically for the study, for the roller skating portion of it. To do that, they basically towed the subjects when they were on their skates by a car and determined the towing force, and they also mounted skates on a board and towed that by car as well. So basically for the coefficients of friction for ice, they assumed it to be 0.006. That was done in previous research, and then combination of these 2 things, they determined the surface friction for roller skating was 0.019. For statistics, they used student t-test for pair comparisons at the significant level of p equal less than 0.05. So we can take a look at some of the tests here. Basically, as we go through here, you'll see most of the comparisons show there was no significant differences, and if there was one, I underlined it in red. So we look at some of the physiological factors here, VO2 max, we talked about that this semester, heart rate. The majority here, again, there was no difference between speed skating and roller skating with the exception of respiratory exchange ratio, which was higher in roller skating than in speed skating on ice. These are the biomechanical tests. This is specifically for the knee. They also did this on the hip as well, and they found no significant differences in any of the categories. So as you look here again, the majority of the tests were not significant between the 2, but we do see some spots where there were differences between the 2. We'll pull those out of the table here in the next slide. Just one more thing on this table to pay attention to is that push-off angle. We talked about that being an important performance characteristic, and if we look at the graph here, we see that it was shown to be the same in both roller skating and speed skating. So looking at the differences between roller skating and ice skating, this is just pulling out those significant findings in that last table. Basically a higher knee joint angle during push-off, a lower push-off trajectory, and a lower knee extension velocity. In terms of the power test, again, we can see we did have some significant findings here, and we'll go on to those and pull those out again in the table at the next slide. But we can see power, work per stroke, stroke frequency, and lap times are all shown to be the same between the two skating styles. Pulling out those significant findings again, we see there was a lower overall speed for roller skating, about 1.74 meters per second slower when roller skating compared to speed skating. There was a higher power needed to overcome surface friction, that was more than double that of ice skating, and there was lower power to overcome air friction. The differences, there are a few differences overall between roller skating and ice skating. Again, that effectiveness of push-off, which we talked about, was shown to be the same, so that's a key component. Why was there a higher respiratory ratio? The authors of the study talked about a few different things, potentially because of the higher knee angle that may influence blood flow to knee extensors. Also the higher body position may alter the breathing pattern, causing a higher respiratory ratio. They really weren't able to pin down exactly why. Also, because there was equal total power output between roller skating and speed skating, the speed must be lower during roller skating because of the fact that there's such a higher component of surface friction, and that's 45% loss of power when roller skating compared to an 18% loss of power when ice skating. And overall, the authors say when you're going to compare these training mechanisms to what you're doing on the ice, you shouldn't really use speed because it is so variable. We should use other things that were shown to be the same, such as heart rate. So in conclusion, roller skating can be used as a specific training activity for trained ice speed skaters during dry land training. And that was because of the obvious similar physiological responses and very few and small mechanical differences. So just a potential future study. Again, this was done in 1987, so this is really when inline skates just first came out. So obviously there's been advancements in that technology, so perhaps a skate like this that mimics better the skate used in speed skating, maybe you'd find even fewer differences between roller skating and ice skating.
Did they do anything with EMGs at all in this study?
No, there was no EMGs in this study. In fact, as I read through the methods, they used the computer they used was an Apple II to analyze all that stuff. So obviously, I don't know if you could do EMGs with that or not. But again, this is pretty old study. In the back, yeah.
This study is about 13 years old, and with the new skates and both, I'm sure there's newer technique to speed skating. Do you think there would be newer discoveries and a bigger difference in a more current study?
Yeah, I think so. I mean, obviously the skates have gone through technology. The only thing that they did for the roller skating, they did it on asphalt, so maybe obviously there's newer surfaces that are better mimic ice conditions, so the combination of newer skates, maybe some of those surfaces is probably worth doing another study on.
When I was reading through this study, I noticed that there wasn't really much of a control group or anything. They were just sort of comparing the two.
Yeah.
Do you think, other than the skates that you addressed, there are any other major limitations that could have been addressed if there was another group to compare it to?
No, it's potential. I mean, we talked about different skates and different surfaces. I don't know a whole lot about speed skating. I mean, you can obviously do different, what they're wearing when they're training. Should they be wearing the same type of outfits that they're wearing when they're actually performing sport, things like that. Maybe they could have expanded on. Yeah.
How do you think the friction would have differed if they did use roller blades now as opposed to the skates?
What was the first part of your question?
The friction.
Oh, the friction?
Differences.
Yeah, I mean, obviously there's been advancements in wheels as well too, but you have all those skates in line, and this was the first study that was the inline skate technique. So obviously I think the friction would be lower just because they're all in line. You don't have many different points of contact side by side. Yeah.
Do you think that the increased power needed to overcome the friction in land roller skating would cause a sooner onset of muscle fatigue or a greater strength increase in those muscles?
Yeah, I think that's certainly possible. I mean, and that may work to your advantage too. If everything else is similar, then perhaps you don't have to work as long, maybe better training, so when you get on the ice, it may seem a little bit easier. Anything else? Thank you.